In this example, we're going to subtract these two complex numbers, and then we're going to write their difference in standard form, a plus bi. So as you see, this problem has a lot going on. We have fractions, we have negatives underneath the radical, so square roots of negative numbers, and not only that, underneath the radical I also have a fraction. So let's tackle these problems one at a time. We'll go slowly through it and try to explain each step as we do it. So the first thing, let's take care of the fractions underneath the radicals. Okay, so we have a property that says the square root of a over b can be rewritten as the square root of a over the square root of b. And in that way we can rewrite these kind of in simpler form, and we can tackle the radicals separately. So let's go ahead and do that first. So I'm going to rewrite the negative 11/6. I'm going to say plus. Now I'm going to break this up as the square root of negative 45 over the square root of 4. Okay, and close up that parentheses, and let's do the next one. So it's going to be the square root of negative 20 over the square root of 9. Okay, so I kind of just took these radical terms that had a fraction underneath and I rewrote it this way. And this will be a lot easier to simplify. Okay, so the next thing is I need to take this negative square roots, okay, and I'm going to rewrite them with i's. Okay, so basically I'm going to do one of these things. So I'm going to rewrite this as the square root of 45 times the square root of negative 1. And of course we know the square root of a negative 1 is going to be our I. So 2/3 minus, so we have the square root of 20 times the square root of negative 1 all over the square root of 9. Okay, so we know that the square root of negative 1 will be our I. And let's go ahead now and simplify all of these radicals. So the square root of 45, so we can simplify that by finding the prime factorization of 45 first. Okay, and it looks like the square root of 45, I'll write it this way, the square root of 45 will be the square root of 3 times 3 times 5. And then of course I have a pair of 3's, and 3 times 3 is 9, so that's a perfect square. So that'll end up being 3 radical 5. Okay, so let's rewrite this now. So negative 11 over 6 plus 3 radical 5 I all over, and this isn't too bad because the square root of 4, that's just going to be 2. Right? And let's go ahead now and distribute this negative through. Probably could have done that a while ago. That's okay. So minus 2/3, and then the negative here make a plus. So we have the square root of 20 that we need to simplify. So again, we'll find the prime factorization, and we'll rewrite the square root of 20 as 2 times 2 times 5, which of course we have the pair of 2's right here. So 2 times 2 is 4. 4 is a perfect square. So this will be 2 radical 5. So I can rewrite this now as 2 radical 5 I over, and then the square root of 9, that's actually really nice, that's 3. Okay? So kind of draw dividing lines here, kind of keep our work separated. Alright, so we have all the radicals simplified and all those imaginary parts simplified. So now let's go ahead and focus on combining like terms. So I have negative 11/6, which is a real part, and negative 2/3, which is a real part. So let's go ahead and get common denominators and just combine those fractions. So it looks like between 6 and 3 I can get a denominator of 6, so let's multiply by 2 on top and bottom. So that'll be a negative 11/6 minus 4/6, which will be negative 15/6, which we can reduce nicely by dividing a 3 out of the top and bottom, and that'll give us negative 5/2. And that right there is going to be the real part. Okay, so let's focus now on how we can combine these two. Well, same thing, I need to get common denominators. So between 2 and 3, I'm going to use 6 again. But for this one, I'm going to have to multiply by 3 on top and bottom. And the coefficient of 3 and this 3 will multiply together. So I'll get plus 9 radical 5i over 6 plus, on this one I'll multiply by 2 top and bottom, and the coefficient in the 2 will multiply to make 4 radical 5i over 6. And this is really nice because not only do we have common denominators here, we also have the common radical terms. So 9 radical 5 and 4 radical 5 will add together to make 13 radical 5 all over that 6. And the I will come along for the ride, again because it needs to be in a plus bi form. So plus 13 radical 5 over 6i, and that's our imaginary part right there. So that actually, everything is simplified. It's in a plus bi form. So that looks like the difference, and we have written it in standard form from this original problem way up here.